Welcome friends. We have seen the convergence of a sequence, limit point of the sequence and Cauchy's criteria about the sequence. The sequence is, we are interested only in convergent sequence. The convergent sequence has a unique limit point. Now, one may ask, if I have two sequences an and bn which are convergents, then can we conclude that the sequence an plus bn, an into bn or an divided by bn are also convergents. Here we will show that if the two sequences are convergent, then the newly constructed sequences that are an plus bn, an minus bn, an into bn, alpha into an are also convergent sequences. Now, let us see, suppose I will write the theorem here, theorem if an comma bn be two sequences such that limit of an equal to a and limit of bn equal to b, then first limit of an plus minus bn equal to limit of an plus minus limit of bn equal to a plus minus b. Second one, limit of an into bn equal to limit of an into limit of bn equal to a into b, and third one, limit of alpha into an equal to alpha times limit of an equal to alpha a. So, these are the three newly constructed sequence an plus minus bn, an into bn and alpha into an, and we show that this is satisfied. Okay. So, let us prove the first. Here we have assumed that it is given that the sequences are convergent. What is the definition of convergence? Mod of Sn minus L is less than epsilon, and here we have to show that limit of an plus minus bn equal to limit of an plus minus b. That means, here I need to show that this an plus minus bn minus a plus minus b is less than epsilon. This is, if this is established, then we get that limit of an plus minus bn equal to a plus minus b. This is we want to show that, this is we need to establish the result, limit of an plus minus bn equal to minus a plus minus b less than epsilon. Okay. Now, I know that limit of an equal to a, that means I have this term an minus a, and second one bn minus b. Therefore, we use these two terms to proving this, right. Now, here I should have to show that these are less than epsilon. Okay. Then here it is given, we write it as here limit of an equal to a, limit of Bn equal to B. So, there for each epsilon greater than 0, there exists m1 comma m2. These are the two positive integers such that mod of n minus a is less than epsilon by 2 for all n greater than equal to m1, mod of bn minus b is less than epsilon by 2 for all n greater than equal to m2. Now, here are the terms. You can see that suppose these are the terms of the sequence a1, a2, an, somewhere is m1, and next one a m1 plus 1, m1 plus 1, m1 plus 2, like this. And here are the terms of the sequence b1, b2, b. Suppose now these are the two numbers m1 and m2. So, there will be one is greater than other, or there is a equality. Now, we assume that this m1 is greater than m2. m1 is greater than m2 means my b1 term is a first, and then m2 term is a first, and then here somewhere I will get m1. So, if this is the condition is satisfied, this condition for all n greater than equal to m2, that means the here the b m1 minus b is less than epsilon by 2, since m1 is greater than m2. This is for all n greater than equal to m2, and m1 is greater than m2. So, this bm1 minus b is less than epsilon by 2, obviously. Or if we put as a particular value, suppose this is my 200 term and this is 100, then the terms of the sequence here, terms of the sequence, which term? This is the 100th terms of the sequence, this is 200 terms of the sequence, then obviously the 200 terms of the sequence b minus b is less than epsilon by 2. Okay. So, we choose a bigger one from m1 and m2, so that for we get the common member, common terms, that is here a 200 terms minus a is less than epsilon by 2, and b 200 terms minus b is less than epsilon by 2. We should choose the number such that the terms of the sequence, the number of the terms of the sequence are less than epsilon by 2. That may, so say let us suppose that m equal to maximum of m1 comma m2. We choose this maximum, that is 200th terms of both the sequence will satisfy these conditions. Okay. So, therefore, for all n greater than equal to m, the difference mod of an minus a is less than epsilon by 2, and mod of bn minus b is less than epsilon by 2. Just we have taken the number of the terms of the sequence, we have not changed any value, we have not changed epsilon, or we have not changed the limit of the sequence. Everywhere is as it is, just but we have taken the terms from above, the common terms from which above both the condition are satisfied. Okay. Now, I have to prove this. So, here an plus or minus bn minus a plus or minus b. Now, firstly we show this for only plus, okay, so that there will be no confusion, and similarly we can show that it is satisfied for minus also. Here an plus bn minus a plus b. So, this is equal to mod of an minus a plus bn minus b. Now, apply triangle inequality. This is less than equal to mod of an minus a plus mod of bn minus b. less than epsilon by 2 plus epsilon by 2 equal to epsilon, and hence I will get the result that the sequence an plus bn is also convergent. Now, let us prove the second. In the second case, I need to show that the term mod of an into bn minus a into b is less than epsilon. And what I know? I know that mod of an minus a is less than epsilon and mod of bn minus b is less than epsilon. I can take this is less than any value and this is less than any value. I can take this, I can use this term, I know this, okay, but I do not know about an into bn minus a and b. So, in order to achieve this an into bn minus ab is less than epsilon, anyhow I should somehow we need to bring these two terms into this an into bn minus a into b, and to bring this term we add and subtract the cross term. Cross terms means here these terms an into b or bn into a, this cross term we add either this term or this term. So, let us see this mod of an into bn minus here an into b plus an into b minus ab. Okay, look at this, I have taken added and subtracted. Now, from the first two terms an common, an into bn minus b plus b common an minus a. Now, you can see that by this small trick I will get this term mod of bn minus b and mod of an minus a, which I known to me. Now, this is less than equal to mod of an into mod of bn minus b plus mod of b into mod of an minus a. Now, here I can take this less than any value, I can take this less than any value, but here is the general term. Now, we can we have that limit of an equal to a. Therefore, this sequence is convergent. Convergent means bounded. Okay. Bounded means there exists k such that mod of an is less than k for all n. Now, let us put the bigger value in this inequality, so that mod of an into bn minus ab is less than or equal to k into mod of bn minus b plus mod of b into mod of an minus a. Now, the total term should be less than epsilon and we have this. Therefore, we should arrange these in such a way that the sum of these equal to epsilon. Since limit of an equal to a, once again I can take mod of an minus a is less than epsilon divided by 2 into mod b plus 1. Okay, why I have chosen, I have taken plus 1? Since it is possible that this converges to 0, and in that case I cannot write this as epsilon by 2 divided by 0. So, I have chosen the bigger term, smaller term mod b plus 1, and here mod of bn minus, it is also limit of bn equal to b. So, for epsilon greater than 0, mod of bn minus b is less than, we choose epsilon divided by k. Okay. Now, let us put this value in this inequality. Here k into bigger value epsilon by 2 divided by k plus mod b into epsilon by 2 divided by mod b plus 1. K will be cancelled, and you can see that this is mod b and this is mod b plus 1. This is like 2 by 3, 4 by 5. Okay. So, this is a fraction term. So, instead of fraction term, I will take this term, remove this term, so that this will be less than epsilon by 2, epsilon by 2. Multiplication to any term by fraction term, that term will be smaller. Here therefore, I replaced here the bigger term epsilon by 2, and here I will get epsilon, that is mod of a n into b n minus a b is less than epsilon, and hence the limit of a n into b n equal to a b equal to a means limit of a n into limit of b n. Second part is proved. Now, third part. In this third part, what we have, we need to show mod of alpha into a n minus alpha a is less than epsilon. Now, it is quite easy. We have this term a n minus a, then we can write this as mod of alpha into a n minus alpha a equal to mod of alpha common a n minus a. Okay, this is equal to mod of alpha into mod of a n minus a. Now, see here, if alpha equal to 0, alpha equal to 0, then you can see that alpha into a n equal to 0 and alpha into a equal to 0. So, the sequence is convergent and there is nothing to prove. Okay. So, we talk about if alpha is not equal to 0. If alpha is not equal to 0, here it is given that limit of a n equal to a, hence mod of we choose mod of a n minus a is less than epsilon divided by 2 into mod alpha for all n greater than equal to m by definition of limit or convergence of a sequence. Then mod of alpha into a n minus alpha a is less than this mod alpha into a n minus a is less than epsilon by 2 divided by mod alpha. Mod alpha get cancelled and we get epsilon divided by here no need to write as a 1 epsilon by 2. So, we take only epsilon. Okay. So, this will be less than epsilon and hence limit of alpha into a n equal to alpha into a, that is equal to alpha times limit of a n, and hence the result is proved. Now, we show that one important result which need to show about the division of a sequence for convergence, and we call that as a lemma. If sequence Bn is convergent, then sequence Bn is convergent, there exists a positive integer lambda and m positive integer m such that mod of Bn is greater than lambda for all n greater than equal to m3. Let us show that. So, in the proof, sequence is convergence for epsilon equal to, let us take mod b divided by 2, and for this epsilon there exists m3 which is positive integer this is my positive integer such that mod of bn minus b is less than epsilon, that is mod b divided by 2. Here we have taken sequence is convergent, therefore limit of bn equal to b suppose, and this is for all n greater than equal to m3. Now apply the triangle inequality. This is means that b mod of b minus mod of bn is less than or equal to mod of bn minus b. Now we can apply the modulus properties. Mod b minus mod bn is less than equal to mod of bn minus b, and this is less than equal to mod b divided by 2. That is, or we can transfer this term, transfer this bn to this side and this b by 2, mod b by 2 to this side, so that mod b minus mod b by 2 is less than mod of bn, less than or equal to mod of bn. But this implies that mod bn is greater than mod b by 2, you can see that, and let us call this as a lambda. Mod b is positive, so we have a positive integer mod b divided by, so this is we have say, so we get that this is less than or equal to m3. Okay, I hope you get that. This is needed to prove next theorem. So remember that we have a convergent sequence, and for convergent sequence limit of bn equal to b. When limit of bn equal to b, there exists positive integer m, and positive integer here m3, let us call as m3 particularly, such that mod of bn is greater than lambda. So we have taken a particular value of epsilon, as sequence is convergent we can take any value. Here we have chosen epsilon equal to mod b divided by 2, and we can see that there convergence means there exists a positive integer m3 such that mod of bn minus b is less than mod b divided by 2. Now applying the modulus property, mod b minus mod bn is less than mod of bn minus b, and mod of bn minus b is less than by here epsilon, that is mod b divided by 2, and hence I will get mod of bn is greater than mod b divided by 2. Okay. Now we apply this result, and we will show that if the two sequences, if limit of an equal to a, limit of bn equal to b convergence, then limit of an divided by bn equal to a divided by b. This is we will prove. Okay. So here friend, we apply the same criteria to prove this. What is needed? What we need to establish? We need to establish that mod of an divided by bn minus a by b is less than epsilon. This is we need to prove. Now you can see that if we but we know that limit of an equal to a, that means I have this term an minus a, I know about this. Again bn is a limit of bn equal to b, that means bn minus b, I know this term. So anyhow, like the previous theorem, I should bring these two terms in this expression. Anyhow, I should include this term in the expression of mod of an divided by bn minus a by b. Okay. So here mod of an divided by bn minus a by b. Let us cross multiply. Mod of an into b minus a into bn divided by b into bn equal to. So, in order to get an minus a, I need a, right, and this b should be common. So, you can see that if we add and subtract a into b, here a into b, then I will get an minus a. So, let us add this and let us subtract this a into bn. This is very easy. If you see this, then you will get that I need this term in this expression. So, you can think that how I will add, how we will get this term in this expression, so that I can apply the knowledge of the convergence of the sequence here, that is mod of n minus a. Now, here easily we can take this b as a common and here a common in these two terms and b common in these two terms, and directly I can write this as mod b into mod of an minus a plus mod of a into mod of bn minus b divided by mod b into mod of bn. Now, friend, okay, so more explicitly, mod of b into mod of an minus a plus mod a into mod of bn minus b divided by mod b into mod of bn. Now, you can see that a and b are known to me, but here is the general terms of the sequence and I want to remove these terms. Now, to remove these terms, we apply the lemma just we have proved. We have proved that for epsilon greater than 0, that is mod b by 2, there is a term bn greater than lambda. What is lambda? Mod b divided by 2. This is lambda, and this is for all n greater than equal to m3. I can use this knowledge. Okay, bn is a greater and this lambda is a smaller. This is like 10 divided by 5. Okay, so you can see that when we divide by bigger term 2, and when we divide by smaller term, then smaller term in the denominator and bigger term in the denominator, we get this inequality. Okay, when the term is a smaller, it is a greater. So, instead of this, if we replace the smaller term mod b into mod of an minus a plus mod a into mod of bn minus b divided by mod b into here mod b divided by 2. Instead of bn, I have replaced the smaller term. I have replaced the smaller term in the denominator instead of greater term. I have replaced instead of this greater term a smaller term. So, obviously, smaller term will be greater. So, this is less than, greater than, right. Now, you can see that here I will get this. Now, separating this, separation shows that this b and b get cancelled and I will get 2 divided by mod an minus a divided by mod b plus here there is nothing to cancel. So, I get here 2 mod a divided by mod b square into mod of bn minus b. Now, I can take this term less than any value, since limit of an equal to a. Therefore, for epsilon greater than 0, there exists m1 such that mod of an minus a is less than, we take epsilon divided by 4 into mod b, epsilon divided by 4, this is for all n greater than equal to m1. Okay. Now, so let us see some space, we need some space, we delete some part, and you can see that this is less than epsilon by 4 into mod b. Now, here we take that the second term, that is here limit of bn equal to b, therefore, mod of bn minus b is less than, we choose here epsilon divided by 4 into mod b square divided by mod a, and this is for all n greater than equal to m2. Now, I need a common m to all these terms, m3 is here, here is m3. So, I have 3 values, fixed values m1, m2, m3, like this. From m1 or onward, the condition of A is satisfied. For m2 onward, suppose this is greater than m1, m2 onward, this is for onward an satisfied, for here onward bn approaches, and for here is m3, suppose this bn, this condition bn becomes greater than lambda. So, if we choose the bigger for these, then we get the common term here, right. That means bigger for m1, m2 and m3. Hence, let us choose m equal to maximum of m1, m2 and m3, and for this m, therefore, for this m all these 3 conditions are satisfied. What are that 3 conditions? That 3 conditions are, first one, for this m mod of bn is greater than lambda for all n greater than equal to m. What is second? Mod of an minus a is less than epsilon divided by 4 into mod b, right, n greater than equal to m. And what is third? Mod of bn minus b is less than epsilon divided by 4 into mod b square divided by mod a for all n greater than equal to m. Okay. Now, therefore, here you can see that we replace the bigger value for here and here. Okay. So, I have that this is less than, I will get here this is less than epsilon. You can see that then mod of an divided by bn minus a divided by b is less than 2 divided by mod b into mod a. An minus a is less than epsilon divided by 4 into mod b plus 2 mod a divided by mod b square into mod bn minus b is less than epsilon divided by 4 into mod b square divided by mod a. Now, mod b get cancel, mod a get cancel, b square cancel, and this will be 2, this will be 2, right. That is, this is epsilon by 2 plus epsilon by 2 equal to epsilon, and hence here limit of an divided by bn equal to a by b equal to limit of an divided by limit of bn. Hence, we get the theorem. I hope, friend, you have get the idea of how the sequences converges combinedly and how we can construct a convergent sequence from 2 convergent sequence. Thank you for watching me and being with me.